Hey, it's Carol here and welcome to another tutorial in the Automotive Unreal Engine series. Remember our last tutorials? We rigged the car in Cinematic Car Rig, applied Automotive materials pack, generated terrains in Gaia. The car sits on a beautiful landscape, but it looks like Mars. Where are the trees? The grass? And this is where PCG comes in, Procedural Content Generation Framework. Why PCG? Because you generate 50,000 trees in 10 seconds. Client wants a change, one parameter, 10 seconds, done. That's the difference between a week of manual work and an hour with PCG. Let's go. First, we enable the plugin. Search for Procedural Content Generation Framework. Check all related to PCG, restart the editor. After restart, create a folder for PCG in your main content folder. Keep things organized. Now we need assets. We go to Fab, there's tons of free packs. I'm making a forest and road, so I'm grabbing MAE Oak Forest. Alright, in Content Browser, right-click, create a PCG graph. We'll call it PCG Forest 01, so we know exactly what we're doing. Open the graph. Clean canvas, node-based editor, very similar to material editor or blueprints. Now we drop PCG volume on our level. Make sure the volume covers your entire landscape from Gaia. Back to the graph. First thing, add node getLandscapeData. This node extracts all information from the terrain. Height, slope, normal, everything. To this we attach Surface Sampler. This node generates points on the surface. Select Surface Sampler and press D. That's debug mode. Back to the level, select PCG volume and click Generate in Details. And boom, hundreds of points. Black and white squares neatly arranged in rows. This is visualization of where we can place something. Each point is a potential location for a mesh. It's too even and too boring. Let's add diversity. Add node density filter. This node operates on lower bound and upper bound values. The higher value in lower bound, the more darker points we remove. The lower in upper bound, the more bright ones we cut out. Connect Surface Sampler to Density Filter. See? Fewer points, more randomly scattered. But they're still too even. Let's add Transform Points node. In Transform Points, let's set Max Rotation Z to 360, Scale Min to 0.7, Max to 1.2 just different sizes, and important, check Absolute Rotation. Trees grow vertically, not sideways. Connect Density Filter to Transform Points. So let's add Static Mesh Spawner. Connect Transform Points to Static Mesh Spawner. In Details panel of Static Mesh Spawner, click plus. Choose a tree from your MAE Oak Forest pack. Turn off Debug. Wait a moment. First generation compiles shaders. Notice that trees on sloped terrain have a bugged bottom, they stick out beyond the terrain. Now let's randomize even more. In the same transform node, in Offset Min and Max, set values so the trees nicely sink into the terrain. And we have a forest! Pretty nice forest across the entire terrain. Alright, but let's say we don't want trees on the entire terrain, only in a specific place. For this we'll use splines. Create a new actor blueprint. Call it BP Spline. Open the blueprint. Click Add Component and add spline. Add about 3 points on the spline. In Details, check Closed Loop. Let's change the blueprint name to BP Spline Closed. Place it on the level and set the area where we want trees. Add a tag to it. In Details, Actor Tags Add Spline Closed. Back to PCG Graph. Add node getSplineData. In Actor Filter, set all world actors. Actor selection appears. Set to by tag. Enter tag Spline Closed. Splines have their own samplers. Connect getSplineData to Spline Sampler. Nothing happens? Because for now, points generate on the curve at the location of spline points. In Spline Sampler, change option to Interior. They appeared, but they're not on the terrain, floating in air or underground. Add Project Node. In Project Node, set target to your landscape data. Now points are exactly where the spline is. everything in a simple and clear method. Now we can easily copy our previous logic. Take transform points and density filter from the previous tree branch. Copy and paste to this path. But wait, we need to add attribute noise node before density filter. In attribute noise, input density. Because filters need density to work, attribute noise generates random density for all point. Important advice: projection is best placed at the very end or almost at the end. Why? If we decide to change position in X or Y on terrain, elements on sloped places might be either under or above terrain. Of course, if you're doing filters by height, then projection earlier is necessary. But that's a topic for another tutorial. Let's select all nodes responsible for trees. Press C and name the frame that selects them trees. Organization is key. Alright, we have trees. Now let's make grass and plants. Copy a few first nodes: spline, sampler, attribute noise and density filter. In attribute noise, change seed, so it has a different randomness pattern. There's more grass than trees, so in density filter set lower bound to a lower number. Again, add transform points with 360 max rotation Z for random rotation, but this time without absolute rotation. Grass adapts to terrain. And scale from 0.6 to 1.2. But wait, we don't want grass where there are trees, right? Add difference node. In difference, density function. Binary. Mode, discrete. This ensures the best effect. Connect source input. Output from difference goes to static mesh spawner. If you click before and after, you can see which points dropped. In static mesh spawner, add some grass from your pack. Generally cool, but a bit too regular. In transform node, let's add offset min and max some values in X and Y. For example, min pinch 50, max 50. This will randomly shift points in those axes. We don't need to worry about position on terrain, because we do projection after the shift. And if you want more grass, in spline sampler, in interior sample spacing option, put a smaller value than 100. The amount of points will increase, grass will be dense. Want to have natural grass patches instead of uniform distribution? Add node spatial noise between project and attribute noise. It's like a big fractal. Play with brightness, contrast, transform or offset to get the effect you're interested in. At the end again, density filter and we're rolling. Now grass isn't everywhere evenly. There are natural clusters and empty spaces. You can add to all this several other types of trees, different types of grass, rocks, logs or other obstacles. Just duplicate the path, change meshes, tweak parameters. Each layer uses difference to not overlap with previous ones. Actually, we have a road on terrain where it would be silly for trees to grow, right? Let's create another blueprint spline actor. Name it BP Spline Road. Open, add component spline, but this time don't close it. Compile, save. Place on level and drag roughly where the road is. Add tag spline road in out blueprint. Back to PCG graph. Add get spline data, all world actors by tag spline road. Add spline sampler, but this time set to on spline. And mode distance. Add bounce modifier. Set some damn big values to see what we're doing. Get spline data to spline sampler to project to bounce modifier. Now add another difference node to our grass before static mesh spawner. Connect source our grass path and difference, bounce modifier from road. As you can see, where the road spline is with large bounds around, grass doesn't generate. We have a clean road. You can use this same option not only for the road. You can throw several splines, you can make closed splines for area separation. Remember, you can add more meshes to each spawner. You can also use bounce modifier plus self-pruning to make sure meshes don't overlap, especially important for large objects like trees or rocks. In console, you can also type r.force_LOD0 to always see the highest mesh quality during work. All this together gives you full control over procedural generation. It's a production-ready tool in UE 5.7. And the best part? This is just the beginning! In 5.7 there's also procedural vegetation editor, nanite foliage, megalites, substrate materials. Everything comes together into one powerful pipeline. I hope I managed to guide you through the entire process in an enjoyable way. If you like this video, feel free to subscribe. My name is Karol and see you next time.